We are the Lethbridge High School iGym team. We are made up of grades 10 to 12 students from various schools around our city who all have a passion for synthetic biology. Researching and discovering solutions to world issues through STEM technologies is what we work towards. We present BoFind, a rapid detection device using LAMP technology for the identification of bovine respiratory diseases in cows.
Bovine diseases in cattle. Mannheima hemolytica and Pasteurella multocida are the two most common bacterial infections that lead to bovine respiratory disease in cattle. These bacteria affect mainly the respiratory tract and can lead to pneumonia and death. Infection is spread through contaminated feed and water and directly from animal to animal through respiratory secretions. Cattle that are most prone to severe outcomes are young calves, cattle that are stressed, and those that have other comorbid conditions or pulmonary disease. Feedlot cattle are at risk due to close proximity of living conditions. To adequately treat infected cattle and prevent transmission within an entire herd, it is important to have timely and accurate diagnostic tools. A delay in treatment can lead to increased severity of illness in cows, as well as entire herds that are impacted. Ultimately, these impact animal well-being and cost to farmers.
We propose testing for these diseases using LAMP. LAMP is a diagnostic method that allows for rapid detection by replicating or amplifying small sections of genetic material at a constant temperature. Our initiative is to create a rapid detection test with a colorimetric characteristic. This design simplicity will make it more accessible to veterinarians, farmers, and our government. We aim to construct it out of sustainable materials that are easily recyclable in order to reduce medical waste emissions in our community and the environment.
Dr. Kim Stamford helped us to narrow down the diseases we are developing the LAMP rapid test for. Why LAMP? As of right now, when a cow is sick, it is treated with rounds of antibiotics, which can be ineffective, costly, and contribute to the bioaccumulation of ARGs, antibiotic-resistant genes. The detection of disease is a lengthy process requiring specialized equipment and specific biological protocols. It is done off-site, which can be tedious, costly, and needs to be done by trained professionals. Our solution would be more cost-effective, easy to use, take less time, allow for point-of-care testing, and not require large environmental samples. We discussed it with Dr. Kim Stamford, cattle expert, and identified the diseases that pose the greatest risk to cattle health. With the rapid pathogen detection, BoFind would allow farmers and veterinarians to diagnose and treat affected cattle more efficiently.
The first problem we'd like to tackle is sustainability. Using the 17 goals to transform our world, in number 12 falls responsible consumption and production. Responsible consumption and production looks like not overproducing, producing in an ethical manner, using environmentally friendly production spots that pay their of-age workers proper wages. With responsible consumption, the target audience plays a substantial role, and ours is vets and potentially government officials. This product wouldn't be found at your local drug mart. Ethical production is our goal. We can achieve this by hiring adults, not children, which are paid fair wages and safe conditions to work in. Also, a place that doesn't negatively impact the environment. Using those same goals, we have 13, climate action, and 14, life below water. We can start by making the device using recycled materials or biodegradable material and ensuring that the packaging is environmentally safe, meaning no microplastics and no dyes or parabens that can impact the environment negatively. Our recommended method of disposal would be separating the waste from your garbage and having it undergo material recycling or thermal treatment. At number 15, we have life on land. This would greatly benefit the cattle population and things impacted by them in their ecosystem. We would also like to focus on avoiding our product ending in a landfill by putting it through an in-depth recycling process. And lastly, finding antibiotic-resistant genes would not only help the cattle, but can go as far as to help people track them so it doesn't end up inside us through our waterways.
Our solution will be mainly used by veterinarians and government researchers to monitor disease in cattle populations. Farmers also could quickly use BoFind on-site to diagnose the disease and give the correct antibiotics to prevent symptoms from worsening. which allows farmers to quickly provide care to cattle without having to wait for a veterinarian. This can also prevent the spread of ARGs into the environment, which can pose a threat to public health and the effectiveness of current antibiotics. An added benefit is that it can decrease the use of antibiotics that are not needed, increasing the sustainability of antibiotic efficiency. Farmers, researchers, and veterinarians alike will be able to use bovine easily due to its colorimetric testing and not needing a large environmental sample. Developing the rapid detection test. The engineering of the device will be done in a web lab, getting the LAMP technology and compacting it into a small, simple, fast, and cost-effective test, while using an environmentally safe plastic such as PHA or polylactic acid. So when recycled into medical waste, it can be safer for the environment. Picking a control factor. One spot on the device will be dedicated for a control factor, which will be present in all samples to indicate whether or not the device is functional. The control factor is still unknown currently, but potential options could be DNA itself in the cow's antibodies. Expanding our reach. This will be the end goal of the project. At this point, the device will be produced and used by local vets, scientific researchers, government agencies, vet techs, and potentially farmers.
Thank you so much for watching. We hope Bovine will improve the detection and diagnosis of respiratory diseases in our fellow bovine friends.